Hello, welcome to the fifth grade science summer course open house. I'm going to be telling you about the fifth grade summer course offered starting next Wednesday. So this course is once a week on Wednesday from 6 o'clock to 7:30. So let me first introduce myself. My name is Galen Tracy. I'm an educator in the Houston area, having 7 years of teaching fifth and sixth grade science experience. During those 7 years, 2 of the years I served as a head of the middle school science department, which was a lot of fun. I really enjoyed the opportunity to teach other teachers and share some of the tools I came across that I found useful. I obtained my bachelor's degree in general science with teaching from Temple University, completing the UTeach program developed at the University of Texas in Austin. So the original program was first developed here in Texas. Great program. And what sets it apart from other schools is I started teaching a lot earlier than other people that were studying teaching. So it was like the first semester, you get an experience of what teaching in the classroom is actually like. So I'm looking forward to using my skills in teaching inquiry-based personalized instruction to engage students in learning important scientific skills and concepts with real-world applications. So in every lesson that I teach, I try to elaborate on why the information is useful to students because it helps to keep it interesting and memorable. I also love learning about technology and new ways to be more efficient as a teacher. So I actually did 3 levels of certification using Magic School, which is really useful when you're trying to generate new curriculum from scratch. During the regular school year, I typically teach about 2 sports per school year. It's usually soccer and track, or sometimes it's tennis. So that's my background. This is where the program fits into the rest of the courses offered at Momentum Learning. So if you look in the bottom right, you'll see a QR code where you can learn about Momentum Learning's science curriculum. So as we can see, the fifth grade course gives eligibility for taking the Science Bowl courses, which, in case you don't know, Science Bowl is basically like an academic competition with a science focus. So it's basically like structured academic trivia. So if you're a competitive student, that might be something you're interested in. So we can see that the Science Bowl course opens up eligibility for taking pre-AP biology as well as pre-AP chemistry and physics. Right. So if you want to learn more about what other courses are offered and how this course affects your eligibility for other courses available from Momentum Learning, go ahead and check out that webpage linked with the QR code. And you will be sent a copy of this presentation for reference later. All right, so let me give you a brief description of the focus of the course. So the fifth grade science course explores fundamental concepts across various scientific disciplines, including life science, physical science, and earth science. Students learn about ecosystems and organisms, basic principles of matter and energy, and Earth's processes such as weather and the water cycle. The course involves hands-on experiments and virtual labs that are designed to develop scientific inquiry skills, engage curiosity, and build a foundational understanding of how science explains the natural world. So as you can see from the dates, the first session will be June 18th, and this program will run all the way up to September 3rd. So notice there's no holiday for this course, so it will be every week during that time period. All right, so now let's talk about what the specific topics will be that'll be covered in this course. So as we can see, the primary focus of the fifth grade science course is physics. So the first 2 weeks will be an introduction to motion. There'll be virtual labs and activities. We'll learn about how to calculate speed, velocity, and acceleration, which will bring us to the next topic, which will be understanding force. That'll be week 3 and 4. The next topic covered will be exploring energy and matter. So students will learn about the different forms of energy and their interactions with matter through online readings and virtual experiments. Week 7 and 8 will be sound and electricity. So you'll learn about sound waves and electricity and how it travels through currents and the basic components of a circuit. And then the final topic will be magnetism, light, and atoms, right? So it'll be more focused toward the chemistry side of physics, which will prepare us for the next course. All right. So as you probably know, Momentum Learning's learning management system is Canvas, which is very easy to use for students, and it's pretty easy to navigate as well. So you can see each week the course material is organized by modules, right? So just for our purposes, weeks and modules are the same thing, right? So if we're looking at what are the handouts for the next session, we would determine what week we're on, and you would find everything you need. Now, typically, I publish all of the handouts at least an hour before the course starts to give you time to print any handouts, which I generally recommend because it's a lot easier to follow and have a place to write your answers if you print the lab sheets ahead of time. It's also useful to keep the notes, and I'll show an example of that because the notes is basically a summary of everything covered during the course, right? The main ideas and concepts. So if you wanted to go back and review a topic, and we will periodically every 4 to 5 weeks, you're able to do that. So typically the way I structure it is we'll have 4 to 5 weeks of lessons. Then the next week will be entirely focused on review. It's a lot of fun. We play Science Jeopardy. I divide the students up into 2 teams, and we compete answering questions. And I'll show you an example of what those Science Jeopardy games look like later in my presentation. All right, so as we can see, all materials, including recorded sessions, will remain accessible on Canvas for an additional 3 months following the conclusion of the camp. So you'll still be able to access the resources 3 months after the last session. We'll be using Zoom and Canvas. You'll be sent a Canvas invite. So this will go to the students enrolled in the course, not the parents, from Instructure Canvas about 4 to 5 days before the class start date. So that way you have time to accept the invitation and be connected to the resources before the first session. Now, homework is given once a week. So it's one homework assignment, typically 30 multiple choice questions based on what was covered during that session. That'll be due at the beginning of the next session. So you have a week to work on any individual homework assignment. Let's see. So there's also a Zoom link on Canvas to make it even easier to connect during the classes to the Zoom call. All right, so here's the contact information for Momentum Learning. If you want to learn more about the courses offered, it is momentumlearning.org. Here's the phone number should you need to call Momentum. And here is the email to use. All right, so what I'm going to do now is I'm going to take you through a demo lesson, right? So I'm going to be using resources from week 11 of the course, so you get a true sense of what the class is actually going to be like, the structure. So I'm going to basically talk my way through the lesson plan to show you what you can expect, what you have to look forward to. So typically I would begin the lesson by playing a warm-up video. And this warm-up video is basically just a brief summary of one of the concepts covered during that session. Pretty easy to follow. Most of the videos are less than 10 minutes, so it's easy to pay attention and stay engaged. And that video will typically be followed by 5 multiple choice questions just to make sure that everyone is listening and understanding. All right, so I'm going to play a brief segment of the video just so you can get a sense of what kind of videos to expect during the course. I won't play the whole video because it's just a demonstration. All right, so here's one of the
Professor
videos.
Dave here. I want to tell you about magnets.
He knows a lot about science stuff. Professor Dave explained.
We have known about the magnetic properties of certain types of matter for thousands of years and have long utilized this phenomenon for navigation in the form of a compass and also to display good report cards on the fridge. A few different kinds of magnets are instantly recognizable, like the popular horseshoe variety.
All right, so as we can see by the video, the topic of the week 11 lesson is magnetism. So learning about magnets, what they are, what are natural examples. Students will learn the difference between the north and the south magnetic pole and how they interact. So here's some example questions that I would ask students after playing the video. What are 2 types of poles on a magnet called? A, north and south, B, up and down, C, left and right, or D, hot and cold? So I would pose the question. I would give students, let's say, about 15 to 30 seconds to think about the question, and then I would call on someone to answer the question. Now, during a typical session, I make a point to call on every student as much as possible so that everyone is getting the individual attention that they need. And so that I'm not calling on the same student all the time, right? That way more people get to participate, right? So after I've given students an opportunity to answer the question, I would then discuss that the correct answer is north and south. So we would do this for 5 warm-up problems just to get our brains cranking and thinking about the topic and warmed up, right? Because this course is very focused on listening skills. And with all the practice you get during the course, I can pretty much guarantee that by the end of the course, you're going to find that your student, your child, has improved. All right, so what I would do next is introduce the topic of the lesson. So in this particular week, the topic was magnetic forces. All right, so this is to give you a sense of what did the notes look like that I provide students with. So as you can see, I try to make them colorful, concise, right? We have our vocab words highlighted in bold to make it easier to see what are the main words that I need to know for this lesson. We have some pictures. Now, typically during the regular school year, when I'm teaching in person, I recommend that students take notes and keep a notebook. And I would give the same recommendation to people that want to take this course as well. So you don't have to go out and buy a notebook, but it would certainly be helpful. And just in case you don't have that, you could always take notes on loose leaf paper. There's a lot of research that supports that students retain more information when they're writing things down. So while we could just say, okay, print the notes, look at it, read it, there's more to be learned by actually writing it down in your own words, which I recommend doing as we go through the main ideas. All right, so we can see the next topic in this lesson was magnetic force and energy. So more vocab words are introduced. Depending on the lesson, sometimes there will be equations that students need to write down. And depending on the topic of the lesson, Some of the practice problems would have more of a math focus where students are calculating an answer. Right, so that gives you a sense of what the notes are. They're typically anywhere from 2 to 4 pages long. The longest ones are 4 pages. The shortest ones are 2 pages. And something to keep in mind is even though that may sound like a lot of the space on the page is taken up by pictures and diagrams. So when it comes down to it, it's really not that many sentences on any given page to record. All right, so the next thing that I would do after we go over the direct instruction, which is what the notes is, we would go over 10 multiple choice practice problems. So just like the warm-up, I would go back to my presentation slides, and we would go through 10 problems that are based directly on the notes. All right, so this engages our short-term memory, our listening skills to make sure that we're really understanding the lecture part of the lesson, because that's going to determine what kinds of questions students need to answer for the homework. And the point of the 10 practice problems is to give students specific problems like the homework problems so that they're prepared for it. All right, so we go through 10 problems, and just like the warm-up, I would give students time to think about their answer, vary who I'm calling on, and then go over the correct solution. So at that point in the lesson, I would introduce our lab. Now, depending on the topic of the lesson, sometimes the lab is a worksheet, but many times the lab is appropriately titled a virtual lab. So I'm going to show you an example of what one of those virtual labs in the course looks like. Right, so this is the lab that students will be doing week 11 of the course. Right, so I'm also going to show you a real Canvas page so you can see how the course is organized. Right, so we can see right here we are in the summer course. We're going down to week 11. We're looking at the lab sheet. So when we have a lab, before I let students loose and have them start answering questions on the lab, I would give basic instructions. We'd read through the background together, if there is one, and I would walk the students step by step how to approach the problem. And then what I typically do is I chunk it. So we spend about like anywhere from 6 to 10 minutes per page, depending on how difficult it is. So I give students about that amount of time to work on it independently. And after that time period is up, we go over the solutions for that page and then repeat. So I would give any specific instructions that are needed for page 2, the tutorial, and then more time to work on it. And then we check in, we go over the solutions. So typically, the lab section runs about, let's see, anywhere from a half hour to 45 minutes of the hour and a half course is how much time is spent on the lab. What I like about them is they are to the point, they're easy to follow, and they're interactive. So let me show you an example of that. So for this one here, this is a good example of one of the resources that we'll be regularly using in the course called PHET, P-H-E-T. So this is basically a great free resource that gives math and physics simulations. And what I like about it is once students have answered all of the questions on the lab sheet, they're then free to explore other parts of the simulation. So if they want to test particular ideas, like a hypothesis, like what happens if I do this, they're able to do that. So in that way, they're a little more interactive than something that's like step one, do this, step two, that's more linear, is what I'm trying to say. Right, so there's an example of what one of the labs look like. Right, so the lab, we would start and finish during this session. Right, so by the end of the session, everyone's finished all of the pages of the lab. That way it doesn't add to the amount of assigned work that students have to do for the next session. Right, so by the end of the Zoom call, lab is already done and students can focus on the 30 multiple choice homework problems, which they have a week to complete. All right, so what I want to show you next is what the unit reviews look like. So I have an example open to show you. So like I said, every 3 to 5 weeks, we'll have a week that's entirely dedicated to review of what was covered during the past couple weeks. So here's an example of a review. So this would be the week 5 physics review. And I'm going to stop the screen share temporarily because the menu is blocking the screen I need to see. Oh, wait a minute. I have a better way to do this. Right, so we're going to go to modules. And I'm going to pull it up from Canvas. All right, so let me go back to full screen. Go back to screen share. And let's look at week 5, because that's where it was. So modules. Week 5. Here we go. All right, so this is what the review or a typical review would look like. So there's a couple parts to it. This right here is the solutions to the Jeopardy game that we would play during that session. So this is published after the session is over. That way, no one's able to cheat and the game is more fun because students aren't able to just look up the answer. All right, so that's what the Jeopardy review looks like. What I want to show you is what the study guide looks like. So that would be this attachment here. Right, so the study guide is basically just going to summarize the past couple weeks. It's going to include any relevant vocab terms and definitions. Right, so we can see during the first 4 weeks, the vocab words are position, reference point, motion, distance, speed, velocity, acceleration, force, net force, and inertia. You can see there's some more vocab words and some equations that'll be covered. For example, Newton's second law, F equals ma, force equals mass times acceleration. You can see that the study guides also contain example problems, right? So if an equation is introduced during those weeks, there will also be at least one example problem for students to look back at. Right, so it's kind of like a summary of the notes for those previous weeks. Right, so students will get these an hour before the session starts so that you have time to print it. And this will be one of the first things that we go over during the review week. Right, so I would go over frequently missed problems on the previous week's homework first, and then we would transition to the review, starting with going over from cover to cover this study guide. And then we would do like some practice problems, but most of that review session would be dedicated to the Jeopardy review game. right? So what I want to show you next is what the Jeopardy questions look like. So another great resource that's frequently used during my course is Jeopardy Labs. And what this allows us to do is it allows us to easily keep track of teams as well as score, right? So let's take one question, for example, right? So we use a virtual buzzer that looks like this. And what this allows students to do is once they go to this website and put in the code, their name and team number, students have a virtual buzzer that they can click on, and this website will tell us exactly who buzzed in first. So that would be the first person to get the opportunity to answer a question. If they answer incorrectly, we go to the next person on the buzzer list. We go all the way down the list. In the event that no one gets the correct answer, we're still stumped, I would give another clue, additional time to discuss the question. So we use breakout rooms for the teams so that students can talk to their teammates before it's time to buzz in. All right, and then let me show you an example question here. So let's say I ask this question, how is net force calculated? And a student correctly answers that net force is calculated by subtracting opposing forces and adding like forces together. Net force is in the direction of the larger force. So let's say this person was on team one. I would add the points to team one. And as we can see, it keeps track of which questions have been answered as well as how much points each team has won. All right, so that about concludes my presentation, and I hope it gave you a better sense of what to expect for the 5th grade summer course. I hope to see some of you next week during the first session. Before I go, I'd like to open up the floor to questions. So does anyone have any questions I can answer about the course? So feel free to unmute and ask your question if you have one. All right. Well, if no one has any questions, I'm going to go ahead and end the Zoom call. And like I said, I hope to see you next week. Have a great one. And thank you for your time and for listening to my presentation. Have a good one.